So I don't have to run classes, but because I'm nice, I'm running classes. If no one turns up, I'll stop running them. Okay, so the classes are for your benefit. Come along if they're useful. So I'll set exercises every day, every week, and then we'll go over the exercises in the following class. So the geniuses in scheduling decided that it would be a good idea to put the lecture on Monday evening and the class on Tuesday morning. So the people in scheduling think you can do all your work in one evening. In practice, it's kind of crazy. It's probably not going to happen. So what I expect will happen is that the classes will gradually lag behind the lecture. Okay, so the class will, in the following week will be doing the lecture from the previous week. So you've got a week to work on that. But we'll have a class tomorrow anyway and see where we go from there. Okay. So yeah, do come to the classes. You know, there'll be a lot of going over maths on the board in the classes, a lot of seeing how you actually solve problems. You know, it's going to be hard to do well in the final exam if you haven't come to the classes, so it's a good idea to turn up. Classes are going to be, so tomorrow, Tuesdays, 11 till 12 a.m, and they're in the management school, 32 MS, so 3. In week 6, the classes are going to be in a different day, different place. And I'll remind you when we get to week 6, okay? I don't expect you to remember that. So the website is io. The website is io.tholden.org, or if you just go to tholden.org and then click through. Okay, if you go to tholden.org, you can click through to it, but going to that address should take you straight to the website. If you go to SurreyLearn ought to automatically redirect you to the website, or if it doesn't, will be a big link saying click here to go to the website. You know, I will put things on put the slides at least on SurreyLearn, but it's better to go to the website because the website has the videos. You can comment on each post. You know, it's a bit nicer than SurreyLearn generally. And all of the previous year's slides are on the website, okay? So if you want to read ahead, you can just read last year's slides. Essentially, we're going to cover the same stuff as last year. There will be some tiny tweaks of slides here and there, but only very, very minor ones. It's just possible that if you guys are super smart and we get through lots of material, then I might have one more topic at the end, okay? But otherwise, feel free to read ahead. Okay, you can read ahead, watch the videos from last year. You know, you kind of completed this course by tomorrow if you really wanted to stay up all night watching videos of me.
Can you just try you can see something
Well, if you have it on extend rather than duplicate, then you know the difference. It's working from a PC.
Yeah. Yeah. Don't worry. Well, the best thing is if you can arrange for instruments free, let us know. We'll come back up with you and we'll try and find a solution for this.
Okay, so the readings for the course, I'm sorry about this disruption. Readings for the course are OzSci. It's called Industrial Organisation Theory and Applications. The library has quite a few copies. Normally I don't have so many students, so I guess you'll be fighting to get your copy. But you can always ask the librarian to buy some more copies or buy it yourself. It's not too expensive, I think. So that's about the right level for this course. It's very hard to find an industrial organisation textbook which isn't either too mathsy or too, here's a graph, this curve moves up like that. So we kind of want to be somewhere in between those two. Oshai seems to be about in the right place. If you think you're one of the smart kids and you want a harder textbook, Jean Tirol's Theory of Industrial Organisation is the kind of the go-to textbook for the topic. Tirol won the Nobel Prize, so this is a hot topic. And you know, one of the things he won the Nobel Prize for was that his work on industrial organisation, a lot of which is summarised in that textbook. So be up to date. And the other textbook which is a possibility, so there's a Church and Ware textbook, which is available for free online. It's a little bit, it's not quite right for the course, but it's free. You can download it legally for free. So maybe it's a good emergency textbook if you don't have access to the others. And then there's always Google and Wikipedia as well. You know, people are rude about Wikipedia, but it's actually very good for economics these days. One of these days we're going to get the slides. Can't type. Okay, so in previous years I've had 2 mid-tests during the term. So there used to be a 10% test at the start of the term, and then a 20% towards the end. And then last year I replaced the 20% test by an extended essay, and the students, they didn't really respond to that particularly well. So this year I've made things even simpler. There's just one test which is worth 30%, which is happening in week 9. Okay. So I think a lot of courses are doing this now, having just one test. So that will be mostly short answer questions. And it's going to be 110 minutes long, so basically it's for full lecture. Okay, so you come in and then you'll do the test. So it'll be fairly mathsy, that test. You won't have to write too much. Where are we? IO. Okay, where are we? Exams and timetable. Okay, so yeah, midterm test, week 9. I'm going to give you a mock, obviously. The mock test will probably be quite close to the test you actually get. Okay, I can tell you that in advance. So because it's going to be quite close, I'm not going to be giving answers to the mock. So it's a two-edged sword. You know, on one hand, if you practice hard on the mock, if you can do the mock and questions similar to the mock, you're probably going to be able to do well on the test. Then the final exam is going to be broadly similar. There will be a short answer section, which will be kind of similar to the things you've seen in the midterm, and then other longer questions, multi-part questions, where will be some mathsy bits and then some waffly writing essay bits. Okay, it's mostly quite a mathematical course, because that's how economics is. You know, we're always going to be thinking about what the applications of the maths is, but the maths is inescapable, I'm afraid. And obviously I'll give you a mark. So for practice questions, Oshai's book has lots of exercises. If you do them all, you'll be much better placed in the final exam than if you don't even look at them. So, so do actually do those questions, and hopefully the answers are all online. Okay, so have a go at the questions in the book first, don't look at the answers until you've had a good go, then go online, look at the answers. And then he's got some additional problems as well. The additional problems are at this link. If you go to my website, you know, if you look at these slides online, these links are clickable. Okay, so you don't have to copy things down, and the solutions for those are online as well. So you've got lots and lots of practice exercises to do. The more you do, the better you're going to do in the final exam. And I'll be sending a few questions during the lectures as well. Okay. So what am I going to cover today? Well, given that 20 minutes has gone already, maybe not all of this, but as I suppose a lot of you are thinking whether you should take this topic or not, so I'll give you some outline of what I/O is and what we're going to be doing in the course. And then we'll do a bit of revision. I guess it's a while since you've seen these things. You know, you probably saw the Bertrand and Cournot models in second year micro sometime, but you know, I want to refresh your memory of these things. If you've been on placement, it's a long time since you saw these things. Yeah, so I'm going to be doing quite a bit of work on the board. Yeah, do take notes of what I do on the board. Okay, so what is I/O? So there is a field of economics called industrial economics. Industrial organisation is not the same as industrial economics. So industrial organisation is not about industry necessarily. It's not, you know, industry as opposed to agriculture. What's I/O about, industrial organisation about? It's about the organisation bit. It's about how firms come together within a market, how they compete, how they behave strategically when there are several firms. Okay, so a lot of what we're going to be doing is applied game theory. So it's about the interaction between firms, and then the policy side of I/O is regulation. So if you wanted to become an economic consultant, there are two things you might be doing. One is kind of applied micro type work, which is running regressions. The other thing you might be doing is industrial organisation. Industrial organisation is a huge field for economic consultants. You know, the government will say, well, let's look at, I don't know, the mobile phone industry. So 3 want to buy O2 at the moment. That's kind of going through slowly. And they'll call up some industrial organisation economists and say, you know, if 3 buys O2, is this going to be good or bad for consumers? Okay, so these are the kind of policy questions that people doing I/O are going to be able to answer. But we might also be interested in, you know, more generally, we're thinking about how a firm is making decisions. Okay, so we'll be looking at entry, exit, and mergers between firms. Should I enter a market? You know, what is it sensible to enter a market? What's going to happen if I enter? When does it make sense for 2 firms to merge? We'll look at research and development a little bit. Okay, so what's research and development? Research and development is spending money now to reduce your costs in future. So there's a cost now that you incur, and then there's some benefit in the future. When's that going to make sense? Well, when you've got competition and other people are doing research and development, these things are going to be a bit more complicated. Advertising is in many ways similar to R&D. We'll talk about advertising. So advertising, you're spending money now to increase your demand later. Capital investment also looks a bit like R&D, right? If you invest in capital, you've increased the maximum that you can produce. You know, you probably reduce your costs a bit as well. And you've also, by incurring a sunk investment, maybe you're telling other firms in the market that, look, you're going to produce a lot, whatever they do. So maybe capital investment can act as a way of deterring other firms from entering your industry. And we'll look at pricing, which is kind of behind a lot of what you do in industrial organisation. Then on the market structure side, you know, we'll be looking at how firms interact. So you saw the Bertrand and Cournot models. There, if you like, the I/O 101 is Bertrand and Cournot. Okay, we'll go a bit beyond Bertrand and Cournot, but that's going to be the base of a lot of our thinking about how firms are interacting. And we'll think about why some firms are big, some firms are small, you know, what does firm size even matter? And we'll think about where concentration might come from. Okay, you know, if you look at the mobile phone industry, there used to be, well, or look at telecoms generally, right? If you include BT, there used to be BT, 3, O2, T-Mobile, Vodafone. Is that everyone? Right? BT are buying... okay, so first was Orange as well. Orange and T-Mobile merged, that's one. Who's BT buying? BT's buying... Okay, so BT's buying, EE, which is Orange and T-Mobile. Okay, so that's 3 firms now gone into one. 3's buying O2. Okay, so we've gone from having 6 firms to having 3 firms. So that's a massive increase in concentration in the phone industry. So we want to know why that's happening, whether it's going to be good or bad for consumers. I've been in the US for the last 6 months, and you think the US is this magic land of competition where everything's perfect. And in fact, if you want a passable amount of data on your contract, you've got to spend at least $40 a month, which is 4 times higher than what you'd have to spend in the UK. So the US has very few big players. Is the UK moving towards US level of prices? Yeah, that's what we're going to be worried about. Okay, so this all falls under competition policy, cartels, collusion. When does it make sense to regulate? Okay, so what are we going to be doing? Well, IO is a very big subject. Keep skipping. Always in our mind we're going to have these practical questions, okay? The practical questions are what drives you to study the economics in the first place, but in order to come close to giving decent answers to the practical questions, you have to build up a lot of technical tools, okay? So we're going to be mostly focused on the technical tools, but just because we're focused on the technical tools, it doesn't mean what we're doing is useless for policy. You should always be thinking about how can I apply these technical tools to interesting real-world questions. Okay, so I'm going to aim to give you the tools that you need in order to go away and think about whether 3 should be allowed to buy O2. Okay, so if you got a job as an economic consultant and you were asked to write a report about these things, maybe you'd have the tools to do that. I'm kind of a theorist by training. So I think the theory is fun on its own. You don't need to worry about having some application at the end of it. So game theory is fun, right? Everyone likes a prisoner's dilemma. If you don't think game theory is fun, maybe this isn't the course for you. So the theory is quite fun. So hopefully you'll enjoy it on its own. Okay, so that's the end of my kind of intro to I/O. Roughly what we're going to be doing. So now let's start reminding you of things that you might have forgotten. Let's go back to Econ 101, demand and supply. Let's start with a demand curve. What the hell is a demand curve? Well, if you're a company like O2, you face some aggregate demand curve. It's a demand curve that's coming from all of the consumers in the economy. Where do demand curves come from? It's useful to think about where these demand curves are coming from. So there are 2 extremes which are useful for when we're thinking about policy. So one world is a world in which all consumers are basically the same, okay? But maybe they want different, maybe they would all like more than one of the product, ideally. Okay, so think about demand for a piece of paper, say. No one wants 1 piece of paper per year. You probably get through quite a few pieces of paper per year. You each have some demand curve for paper. You're all studying the same degree. I expect you all get through roughly about the same quantity of paper. Okay, so it's like you each have your own downward sloping demand curve for paper, and then the aggregate demand curve for paper is just going to be the sum of all of your individual demand curves, but fundamentally the aggregate demand curve is going to be the same shape as your individual demand curve. Okay, you all have the same downward sloping demand curve for paper, and that's just getting multiplied up to get an aggregate demand curve. Another way of thinking about demand curves is in the world where people only want 1 unit of the good. Okay, so think about mobile phones. Nobody needs more than 1 mobile phone. Okay, I don't know, unless you're a city trader or something and you want a phone on each. Yeah, but most people have one mobile phone, right? So you either want 0 or 1 of the goods. So what's an individual demand curve gonna look like in that world? What does a demand curve look like if you only want 1 unit of the good? That's very shy. So you only want 1 unit. Okay, so okay, let's start with the basics. What's this axis? Okay, let's have Q there and price there. Okay, so here's 0, here's 1. So yeah, there's going to be. Come on, someone must be able to figure out what does a demand curve for a mobile phone look like? My personal demand curve for a mobile phone. Come on.
Straight line.
Straight line. Yeah, exactly. So there's going to be. There's. Never have a pen that works. You might want to tilt the camera a little bit so that you can see. If you would mind. Thank you. Okay, can everyone see that? So there's going to be some amount of money, V, that I'm prepared to pay for a mobile phone. Okay? If the price is less than V, I'm going to buy that mobile phone. I'm going to demand 1 unit. If the price is above V, I'm not going to demand any units at all. So an individual demand curve for a mobile phone is going to look like a box like that. Okay, but clearly Samsung doesn't face a demand curve that looks like a box. So where does the aggregate demand curve for mobile phones come from? Okay, well, suppose, you know, I'm antisocial, okay? I don't really need a mobile phone, I never talk to anyone, okay? So I will only buy a mobile phone if it's very cheap, okay? So here's me, if it's very cheap, I'll buy a mobile phone. So price, so this is quantity 1. So there's one person like me who will only buy a mobile phone if the price is very cheap. Okay, what about maybe there's someone else who's absolutely tied to their mobile phone? So their demand curve would look something like this graph about. Okay, so here's 1, here's 2, here's 3, 4. So we're going to have up to 6 mobile phones being demanded. Okay, here's me. I will only buy a mobile phone if it's very cheap. In fact, we should do me last. Okay, let's start with our friend at the front. Maybe you're really desperate to have a mobile phone. Okay, you're prepared to pay a lot for it. So here's your demand curve. Okay, as long as the price is below this very high level, you're prepared to buy a mobile phone. Next person, maybe you're prepared to pay a bit less. Okay, so let's add your demand curve on top of his demand curve. Okay, so here's another one. Here's another person. Here's another person. And finally, here's me. I'm not prepared to pay very much at all. Okay, so we each have our own block demand curves, and they all add up that way. For some reason, economists always draw their graphs inverted to how you'd expect them to be. Okay, so we're adding up these demand curves this way, and that gets us an aggregate demand curve. Okay, you know, this person is only prepared to pay a little bit. This person is prepared to pay a bit more. This person is prepared to pay a bit more. Okay, so demand curves, in reality, people aren't always either perfectly the same or perfectly different, but these two ways of thinking about the origins of demand curves are often useful. So when it's a good where people demand multiple units, it's often helpful to think of everyone as being the same, and then the aggregate demand curve is just the same shape as the individual demand curve. Or when it's a good when people only demand one unit, then it's helpful to think of people having different valuations. Okay, everyone has a different valuation for the good. The demand curve comes from those valuations. Okay, so we denote demand curves by Q of P, quantity demanded at a given price. Okay, you give me a price, this is a function, I tell you the quantity that's demanded at that price. Okay, it's just an arbitrary function. So sometimes we work with demand curves, sometimes we work with inverse demand curves. The inverse demand curve tells you the price, but we clear the market to get a certain quantity Q. Okay, so P of Q. So you tell me a quantity, I'll tell you what price would make that quantity the quantity that's demanded. So sometimes I'll give you a Q of P, and you'll need to work out P of Q. How do you get from a function like this to a function like this? Yeah, you're waving your arms around in kind of the right way. Yeah, so you just invert the function, right? That's what I got from you waving your arms around. So, for example, if your demand curve was Q equals 1 over P, okay, give me a price, the quantity demanded is 1 divided by that price. What's the inverse demand curve going to be? P is 1 over Q, yeah. So all you're doing is just inverting the equation. Okay, you're solving for P in the equation. Right? It's not rocket science. Okay, so we'd like to be able to work with general arbitrary demand curves. In practice, that gets a bit messy sometimes, so we're sometimes going to restrict ourselves to particular classes of demand curves. And there are two which are going to be very analytically tractable. One is linear demand. Okay, it does what it says on the tin. Quantity demanded is just a linear function of the price. Okay, so Q0 is the intercept, Q1 is given the slope, or in terms of the inverse demand curve, we've got the price as some decreasing function of the quantity. Okay, it's linear. So linear is nice. It's very easy to differentiate. The other class of demand curves we're going to use a lot is isoelastic. Okay, so these take the form that the quantity demanded at some price is C times P to the minus alpha. So some constant times some power of the price. Okay, so this is an isoelastic demand curve, right? If we put alpha equals 1 and C equals 1, then that's the same form. Okay, so these isoelastic demand curves are going to have a nice property that in Corno competition you're going to end up with constant markups. Okay, so these are going to generate well-behaved markups. So they're going to be very tractable for certain models. So we're generally going to be working with these two classes. And this is an exercise maybe for you to do in your own time since we're running a bit late, but something you ought to be quite good at doing is getting from the demand curve to the inverse demand curve and back again. Okay, so if I tell you that Q is 2 minus 3 times P, okay, doesn't take a rocket scientist to work out that, what have we got, 3P is equal to 2 minus Q, okay, we're just taking that across, okay, so P is equal to 2/3 minus 1/3 Q. Okay, so we started with a demand curve of this form, okay, so maybe I gave you Q0 is 2, Q1 is 3. Simple bit of algebra will get you to a demand curve, an inverse demand curve in the other form, okay. So that's easy, doing it for the linear case. What about for the isoelastic case? This is a useful exercise. I know it's easy for some people, for others it won't be. Okay, so suppose that Q is, Q is equal to 2 times P to the minus 1/3. Okay, so that's not too tricky. Have a go on your paper for a second. Find the inverse Riemann curve. Q is 2 times P to the power of minus 1/3. Everyone done it? Yeah, okay, it's very easy. You've all done it. Okay, so let's just check that you all done it the same way. Okay, we divide by 2. Okay, that's easy. Q divided by 2 is equal to P to minus 1/3. Okay, so just divided by 2. So we've got P to the power of minus 1/3. How do we get rid of an exponent? Okay, you raise to the power of 1 over the thing. Okay, so if we raise both sides to the power of 3 or minus 3, okay, we have Q over 2 to the power of minus 3 is equal to P to the minus 1/3. All of this to the power of minus 3. Well, these things just cancel out. Minus 1/3 minus 3. Just cancel out and it's just P. Okay, so P is Q over 2 to the power of minus 3. Let's make it a bit nicer. P must be 2 to the power of 3 times Q to the power of minus 3. Okay, because 2 was on the bottom. Right, if you've got something on the bottom, this is like 2 to the power of minus 1. So we've got 2 to the power of minus 1, all to the power of minus 3. That's 2 to the power of 3. So P is 2 to the 3, which is 8. 8 Q to the minus 3. Okay. Everyone happy with basic manipulating powers? There'll be a lot of this, so it's better to get these things sorted now. The rule that you always use is that x to the power of a all to the power of b is x to the power of ab. Okay, so for example, if you put b equals 1 over a, you get, using this rule, you get x to the power of a to the power of 1 over a is x to the power of a 1 over a, which is x. Okay. Yeah, I know this is very easy, but it's better to get these things clear. Okay. So you can do that. Right, the next thing you'll probably remember from first year economics is elasticities. I'm sorry if this is tedious for some people, but it's better to get on the same page, right? So, what's the elasticity of demand? The elasticity of demand is a function. Okay, this is maybe something that wasn't clear when you saw elasticities before. The elasticity of demand is a function of the current quantity, which is given by this derivative. Okay, it's the derivative of quantity with respect to price times price divided by quantity. You know that formula, okay? But it's important to realize that this is going to be a function of of quantity or price. Okay, so there's a question on the slide there. Suppose, so this is in terms of the demand curve. This is in terms of the derivative of quantity with respect to price. Suppose I don't give you the demand curve. Suppose I only give you the inverse demand curve. How are you going to find the elasticity? And there's a hint on the board. So, suppose I give you some function p of q. What's the elasticity going to be? Okay, so we know p of q. We want to find out dq dp. Okay. Have you heard of the inverse function theorem? Did you do this in your maths course in the first year? You probably did, but you probably forgotten that. Okay, so the inverse function theorem just says that the derivative of the inverse of a function is just the inverse of the derivative of the function. So f inverse, that's the inverse function. So if you started with the demand curve, this would be the inverse demand curve. The derivative of that thing is 1 over the derivative of the original function. Okay, so this is just saying that dy dx is dx dy all to the power of -1. Okay, when you write it like this, it looks really obvious, right? But actually, dy dx is this funny thing, so it's not actually that obvious. But okay, so we want to know the elasticity, right? Which is dq dp times p over q. Okay, the inverse function theorem says that this thing here is just equal to dp over dq all to the power of -1 times p over q. So you can work out the elasticity even if I give you the inverse demand curve rather than the demand curve. And elasticities are normally negative, right? That's another thing that people get confused about. Because dq dp is going to be negative. Okay, so the value of an elasticity is normally a negative number. But we say demand is elastic when it's a big negative number. Okay, so it's really small. Or equivalently, when the absolute value of the elasticity is bigger than 1. Okay. So the absolute value of -2 is 2. The absolute value of 2 is 2. So these vertical bars mean absolute value. You know this, you're looking forward. Okay, so demand is elastic when the absolute value of elasticity is bigger than 1. Inelastic otherwise. Okay, maybe these you can do as exercises. Okay, so what's the elasticity for these linear demand curves? The elasticity is going to be a function of quantity. Okay, so for some quantities, demand is going to be elastic. For some quantities, it's going to be inelastic. So you can solve to find what range of quantities demand is elastic for, given a linear demand curve. And with these isoelastic demand curves, the clues in the name, they're going to have constant elasticity over the demand curve. Okay, and maybe I'll go through that quickly now. Okay, so the isoelastic demand curve was Q equals Cp to minus alpha. Okay, so let's plug that into our formula for elasticity. So we want dq, so eta equals dq dp times p over q. Okay, how do we differentiate this thing with respect to p? You were very shy, or very tired. So remember the rule is that dx to the n dx is nx to the n minus 1. You all know that rule. Now, a few years ago, I had someone come to my office hours who didn't know how to differentiate x squared. Okay, so it's important that we sort these things out now before, a week before the exam, someone's not knowing how to differentiate x squared. Okay, so this is how you differentiate x to the n. It's nx to the n minus 1. So we just plug that in here, right? So dq dp is going to be minus alpha cp to the minus alpha minus 1. Okay, so plug it into the formula for eta. We've got minus alpha cp to minus alpha minus 1 times p. Okay, so we get another p, all divided by q, which is what we had before, cp to minus alpha. So how is this expression going to simplify? Go on, you're nodding.
Me? Oh, it's just going to be alpha.
Yeah, it's just going to be, minus alpha. Because we've got p to minus alpha minus 1 times p, so that's just p to the minus alpha. And we've got p to minus alpha on the bottom, so those bits are going to cancel out. We've got c on the top, c on the bottom, that's going to cancel out. So this thing is just equal to minus alpha. So for the isoelastic demand curve, the elasticity is constant and equal to minus alpha. It's not, the elasticity is not going to be constant with linear demand. Okay, so kind of reminded you about demand curves and a little bit of differentiation. So we want to think more about where demand curves are coming from. We want to be able to say, I don't know, if you raise taxes on a certain good, people are going to be better off. If we want to say people are better off, we need to know something about utilities, not just about demand. Okay? So let's give a plausible story in terms of utilities for where demand curves are coming from. Okay, so suppose that consumers have a utility function of this form. So this is what's called quasi-linear. So their utility in terms of consuming some quantity Q is given by some value of consuming a total of Q units plus the value they get for just holding money. Okay, so if you like, people have two goods, Q, the good you're interested in, and M, which is everything else they can do with cash. Okay, and the simplifying assumption is that utility is linear in money. Just clicking forward. Okay. Right. Okay. So suppose they earn a total of Y, and they can buy the good for P. Okay, so the budget constraint is going to be of this form. Income, Y, is equal to their expenditure on buying the good, P times Q, plus M, their expenditure on everything else they're going to buy. So we've got a simple problem. We're maximizing utility, which is VQ, plus M. Okay, and let's work out what M is. M is just Y minus PQ from the budget constraint. Okay, so we want to maximize this thing by choosing Q. We just substituted the budget constraint into the utility. Okay. So when we differentiate this thing, when we differentiate V of Q, this is some function, we're going to get V dashed of Q. Dashers always denote derivatives. Okay, so V dashed is just shorthand for the derivative of V. Differentiate Y is a constant, it's just going to drop out. Differentiate PQ, we're just going to be left with P. Okay, we're differentiating with respect to Q. So the first order condition for these guys, for quasi-linear utility, it says that price is equal to the derivative of this V function. So this, what does this look like? So it's the first order condition, but what kind of object is it? So this is telling you, give me a quantity, I'll tell you a price. Okay, so this is an inverse demand curve. So this is where inverse demand curves come from, right? Demand curves come from the first order conditions of optimizing consumers. I guess you knew this already. In particular, we have this very nice form, right, where price is equal to V dashed. And I said V, you can think of V as like their valuation of consuming in total Q units. So what's V dashed? Well, it's their marginal valuation. It's their unit of it's the value of consuming one extra unit. Okay, so it's like their value of the good. So the first order condition is just saying that price should equal to the consumer's valuation of the good. That's when the point at which they're prepared to buy is the point at which price is just exactly equal to their valuation of the good. Okay, so here's this consumer's demand curve. Okay, quantity and price. And you probably heard about consumer surplus in the depths of your memory, right? And consumer surplus is the area of the demand curve above the line giving the price that they actually pay. Okay, so this shaded area is consumer surplus. Why should we care about consumer surplus? So probably when you've had consumer surplus introduced to you before, it was just said, you know, this is a good thing, this is what we want to maximize. Well, let's see where consumer surplus is coming from. Okay, so we defined consumer surplus as the shaded area, right? So it's an area under a curve, so it's going to be an integral. Okay, so you can't think about consumer surplus without having some integrals on the slide, I'm afraid. So what is consumer surplus? Well, what function are we integrating? Well, this blue line, the blue curve, is the inverse demand curve, right? It's P as a function of Q. So the thing we're integrating is P of Q minus P star, the price we're actually paying. Okay, so consumer surplus, and we're going up to this point Q star, the quantity that they actually consume. So consumer surplus is the integral from naught up to Q star of P of Q minus P star dQ. Okay, you remember what an integral is? Yes. So let's just plug in what we found before. So we said that this thing was the inverse demand curve, V dashed of Q. So let's replace P of Q by V dashed of Q. Okay, so just a substitution. So there are two halves to this integral, right? Remember, integrals are linear. So if you've got the integral of f of x plus g of x, that's the integral of f of x plus the integral of g of x. Okay, so let's deal with this bit first. This is easy. What's the integral of p? Well, it's just a constant. Okay, it's just an integral of a straight line. If you like, it's what's this area here? Well, it's just p star times q star, right? So we're going to get a minus p star times q star. And then we have this first bit, which is the integral of v dashed q. So how do we integrate v dashed? Well, v dashed is a derivative. So what we have here is the integral of a derivative. Do you remember the fundamental theorem of calculus? So the fundamental theorem of calculus says, as you'd expect, that the integral of a derivative just gives you back your original function. Okay, differentiation and integration are kind of inverses to each other. So what you're going to get, if you like, that's for indefinite integrals, you're going to get v of q star minus v of naught. Well, v of naught is just naught. No one gets any value from consuming nothing. Okay, so this thing, the integral of the derivative of v, is just v. Okay, so what are we left with? Well, consumer surplus, what we started with, this integral, is equal to V of Q minus PQ. I said you could think about V of Q as being consumers' valuation of consuming Q units in total. Sorry. So consumers get this much value from buying the products. They pay this much, P times Q. So consumer surplus is what's left. It's the value they get minus what they pay. That's all consumer surplus is. Okay, and you can see now why this is the right thing to look at. Okay, it comes from thinking about quasi-linear utility, and then you get this expression. Okay, if consumers don't have quasi-linear utility, then consumer surplus isn't going to be the right thing to look at. Okay, what we care about is consumers' gain in utility. Consumer surplus is going to be an easy way of thinking about consumer gains in utility when consumers have approximately quasi-linear utility. Okay, so it's a helpful approximation in a world where consumers are almost quasi-linear. So what do I say on the slide here? I said the same thing, I guess. So VQ minus PQ, well, remember PQ is Y minus M. Okay, so, and UQ, utility was VQ plus M. So we've got VQ, let me just write it down so it's clear. Okay, so we started with VQ minus Q star minus P star, Q star, okay. Well, VQ is UQ minus M. Okay, so this is U Q star minus capital M. Okay, PQ is Y minus M. Okay, so minus Y minus M. Okay, minus minus makes a plus, those cancel out. Okay, so we get UQ star minus Y, which is what I said on the slide. Okay, so it's just their utility minus their income. That's what consumer surplus is. Change in consumer surplus is going to be a measure of value gained. And you can think of Y as the utility they would get if they consumed nothing at all. Okay, so that's why we're subtracting Y. We're just kind of making things relative to the case where you don't consume any of the good. Okay, so there are two sides to, Economics 101, you've got supply curve and a demand curve. We've exhausted demand curves at this point. We now have to think a bit about where supply curves are coming from. Well, supply curves are coming from the behavior of the firm, and in particular the cost functions of the firm. Okay, so shall we take a 5-minute break, just a short one, given that we started a bit late. Okay, just 5 minutes, and then come back here and do experiments. Okay, I better get on again as we were late starting. I should have noticed before that a lot of my titles have references to the Oz Shai book. Okay, so like this is Oz 3.1. Okay, so if you want to learn more about the exciting fun of cost functions, that's the section in Oz Shai. Okay, so the references are all in the titles. Okay, so what is a cost function? So you've got some function C of Q, and that's giving you the total cost of producing Q units. You're a firm, you're trying to produce some units, CQ is your total cost. So C dashed of Q the derivative of CQ, that's going to be marginal cost. And of course, average cost is going to be CQ over Q. You know these things. This is a slightly badly phrased question, but the question was supposed to be asking for what type of cost function would average cost equal marginal cost? You can have a think about that. Okay, so where do cost functions come from? Well, cost functions come from production functions. I guess in macro you've seen a million production functions, right? So suppose you produce output using some function like this. Labor is your input, Q is your output, and maybe labor's paid W per unit. What's the cost function going to be in that case? So the question is, how much does it cost to produce in total Q units? Well, if you want to produce Q units, how much labor have you got to employ? Well, you've got to employ the amount of labor such that F of L is equal to Q, right? So to produce Q units, you need to employ F inverse units of labor. How much does that cost you? Well, it costs you W times F inverse. So the cost function is, if you like, the wage times the inverse production function. Okay, the production function is telling you the amount of labor needed to produce a certain quantity. Once you know how much labor you need, you multiply it by the wage, and that gives you a cost, right? So here's a slightly more tricky example. Okay, with a particular functional form. Suppose our production function is this. Q is L minus gamma to the power of alpha. Okay, so in what I did before, what did we do? We just inverted the cost function. So we have to do the same thing here. So let's invert this. So Q to the power of 1 over alpha, that's going to be equal to L minus gamma. So L is equal to gamma plus Q to the power of 1 over alpha. Okay, so the cost function is going to be L times W, which is equal to this thing, gamma plus Q to the 1 over alpha times W. So if I give you a production function, you can work out the cost function. Okay, so we know now where supply comes from, and we know where demand comes from. We know where costs come from, I should say. So what are firms going to do? Well, firms maximize profits. Okay, firms take demand as given, at least for now, and they're going to care about profits. We always call profits pi. And sometimes we'll think about profits as being a function of a price chosen, sometimes we'll think about profits as being a function of a quantity chosen. So if we're thinking in terms of price, well, profits are going to be the price times quantity demanded at that price, minus the cost of producing that quantity in total. Okay, so given the price they choose, the quantity QP is going to be demanded. It costs them C of Q of P in order to produce that quantity. Alternatively, if we're thinking in terms of quantities, so firms are choosing a quantity, well then the profits are going to be the price, but we clear them, the price at which consumers will be prepared to buy that quantity, times the quantity, minus the cost of producing that quantity. And as long as P is Q inverse, okay, so the inverse demand curve is actually the inverse of the demand curve, these two things are going to be the same. Okay, so sometimes it's easier to work with this, sometimes it's easier to work with this. It's going to depend on what you're doing exactly. So this thing is total revenue, right? Price times quantity is total revenue. What's marginal revenue going to look like? What's the expression for marginal revenue? Come on, someone shout it out. I'm sure you learned in first year, but a monopolist sets marginal revenue equals marginal cost. You remember that? So what's marginal revenue in this general case? So first, what's the definition of marginal revenue? It's the change in what as you change what? So it's the change in total revenue as you change quantity, right? It's how much revenue do you get from an extra unit of quantity? Quantity. So it's the derivative of this thing with respect to Q. Okay, so how do you differentiate this thing? So you know this rule, right? du v dx is u dash v plus u v dash. The product rule of differentiation. You know that? Okay, so u dash v plus u v dashed. It's very easy to remember. So we're just applying the product rule to this thing. Okay, so marginal revenue is going to be p dash q times q plus pq times q dash derivative of q, which is just 1. Okay, so marginal revenue is p dash q times q plus pq. So straightforward. You're very quiet. Okay, so here's what you learned in first year. Here's demand curve, here's marginal cost, and the I guess this is the picture you probably saw in the first year, right? So here's the demand curve, here's marginal cost, here's the marginal revenue curve. Okay, marginal revenue is always going to be steeper than the demand curve. Right? This is marginal revenue, P dash Q times Q plus PQ. This is the demand curve, P of Q, right? Will be inverse demand curve. P dash Q is going to be negative, Q is positive. So marginal revenue is always going to be below the demand curve on the graph, right? Because P dash Q is negative. And the monopolist is going to set marginal revenue equals marginal cost. That's what you learned. Well, why do monopolists set marginal revenue equal marginal cost? Let's step back and work that out. So this is probably what you learned, but this grey box was profits. Okay, you know, you probably have this labeled as consumer surplus, producer surplus, deadweight loss. So why is this producer surplus? Well, what is this thing? Well, it's the integral of the difference between a constant of price minus marginal cost. Okay, this is price minus marginal cost, this function. You know, this red line looks quite straight here, but it doesn't necessarily have to be straight, you know. This could be like that. So the grey area is the integral from naught up to q star of price, the straight line, minus marginal cost, and that quantity. Okay, so we're going to do the same thing that we did for consumers. So marginal cost is just c dash q. So price minus marginal cost. Integral of price is just p. Integral of p star is p star times q star. So then we have the integral of this thing. Remember, the integral of the derivative is just the original function. So we get the thing evaluated at the top, q star, minus the thing evaluated at the bottom. So this grey box is p star q star total revenue minus your cost minus or plus your cost of producing anything at all. Okay, you know, even if you produce 0, you pay this cost. So the grey box, if you like, is your profits apart from the fixed cost component. Okay, this is fixed cost. This is what you pay even if you don't produce anything. Okay, so this thing, just rewriting it, the grey box is equal to profit plus C of 0, your cost of producing nothing, your fixed cost. Okay. So if we think about producer surplus as being the grey box, what that thing is profits plus fixed costs. Okay, so if they sold nothing at all, Q is 0, what would their profit be? Well, clearly pi is 0. If you sell nothing, you make no revenue, so your profits in that case are going to be minus C0. If you produce nothing, you just pay the fixed cost, and that's all you get. So that's why the fixed cost is appearing. So when you looked at these things back in first year, or whenever it was, you would have had that welfare was consumer surplus plus producer surplus. Okay, so where's that coming from? Well, let's define welfare as consumer surplus plus producer surplus and see if it makes sense as a quantity. Okay, so we had that consumer surplus was this expression. It's your value minus what you pay. We have that producer surplus was total revenue minus costs plus fixed costs. Okay, so these bits cancel out. Okay, so welfare is just equal to the value consumers get from consuming that quantity minus the cost of producing that quantity, and then add this little correction for fixed costs. So a social planner might like to choose prices and quantities to maximize welfare. So if a social planner is going to maximize the sum of consumer surplus plus producer surplus, they're maximizing this thing by choosing Q. Okay, so we've got to take the first order condition with respect to Q. So here we get V dash to Q, here we get C dash to Q. This doesn't have a Q in at all, so it's just going to drop out when we take the first order condition. Okay, so the first order condition for a social planner is that V dash to Q is equal to C dash to Q. So marginal value should equal marginal cost. So those are terms that you've heard before. So here we've proven that the social planner would like to set marginal value equal to marginal cost. Remember that the consumer's demand curve is just given, inverse demand curve is just given by this function V dash. P was equal to V dash, that was the consumer's first order condition. So equivalently, this is saying that price is equal to marginal cost. So the social planner in this world would like to set price equal to marginal cost. That's the point at which consumer surplus plus producer surplus is maximized. Okay? So that's something that we've proven for any general demand curve now. Okay, I guess you've seen something similar before, but you know, it's good to see things formulate. So perfect competition is going to be what's going to maximize welfare in this world. Okay, but suppose we've got an evil monopolist. Okay, so here's Mr. Google. Mr. Google is a horrible monopolist, setting the prices of Android, or Apple, I suppose, is a worse monopolist. They were all I'm going to get sued for saying that, because it's on YouTube. So what's a monopolist going to do? Well, you kind of know the punchline, but the monopolist is not going to set price equal marginal cost. Let's get there. I'm sure you've seen this before, but we have to go through it. Okay, so monopolist profits are price times quantity minus cost, as we said before. First order condition, well, when you differentiate total revenue, you get marginal revenue. Okay, so it's just what we had on the board here. Applying the product rule to this thing. Derivative of first term times the second, P dash Q, plus the first term times the derivative of the second, is PQ, minus the derivative of this thing. First order condition says at a maximum that thing should be equal to 0. Okay. Remember, this is what we're doing. You know, profits look something like that. At the maximum, it's flat. Hopefully, you don't need reminding. Okay, so this first order condition, well, what it says it's just saying what you learned back in first year, or whenever it was. It's saying that marginal revenue, this bit, has to equal marginal cost. Okay, so this is the proof that marginal revenue equal marginal cost is the solution to the monopolist problem. But, you know, if you had an exercise, hypothetically, involving a monopolist, I don't really like seeing people just writing down marginal revenue equals marginal cost. Okay? Marginal revenue equal marginal cost might not always be the case. You know, you'll see examples where that rule breaks down. You should always think about monopolists as maximizing their profits. Okay, so you've got to think about how do I choose quantities or prices in order to maximize the profits of the monopolist. So there should always be a first order condition with these things. Okay, and then this is what I showed you previously. This is how it looks graphically. Monopolist is setting marginal revenue equal to marginal cost, which is this point. Okay, so that's determining the quantity they're prepared to produce. Given the quantity the monopolist is producing, the price is the price read off the demand curve. Okay, so this area is consumer surplus, producer surplus. We've looked at these before. What you're left with, this triangle, is what's called deadweight loss. It's called deadweight loss because the efficient point is this one, right? The efficient point is when price is marginal cost. If a social planner was choosing quantities, he would choose this quantity here. So this area is measuring the welfare that you're losing by having a monopolist rather than a social planner. So that's why it's deadweight loss. It's the loss that occurs whatever you do because you've got this monopolist. Okay, so there are some exercises here. Okay, so linear demand, linear cost, find the quantity under monopoly, find the quantity under perfect competition. You see that the quantity under monopoly is half the quantity under perfect competition. So you've got, under perfect competition, you get divided by P1. Here you get divided by 2P1. Something divided by 2P1. This is just a nice special property of linear demand. Okay, with linear demand, the marginal revenue is always half the slope of the original demand curve, and that leads to the optimal quantity being half as high. So have a go at solving this, and then we'll go over it in the class tomorrow. Okay. So you all know how you would go about solving this problem? Tell me now before. Okay, so you're going to write down the profit for the monopolist, plugging in this demand and cost function, and then you're going to maximize those profits. Okay, you're going to find what quantity will maximize those profits. And under perfect competition, you're going to find the price at which. Find price where price is marginal cost. And then the last thing I ask here is what consumer surplus, producer surplus, and deadweight loss are. Okay, so you're going to what do these demand curves look like? So we've got, this one is P0 minus P1Q. Okay, so here's P0, it's going to cut the axis at P0. Where's it going to cut the other axis? Where's this line going to cut the other axis? So, equivalently, at what point is price 0? According to the inverse demand curve. So price is 0 if P0 is equal to P1Q, right? Okay, so if Q is equal to P0 over P1. Okay, so this line is cutting this axis at this point here with P0 divided by P1. So we know what this line looks like. You can do the same thing for the marginal cost lines. Okay. In fact, marginal cost is easy. What's marginal cost here? Come on, someone shout out. Yes, I think I heard someone say C1. Okay, so marginal cost is just a straight line. There's marginal cost, C1. So you're going to work out what marginal revenue is going to look like. Okay, it's going to be another line that you can put on this diagram. Okay, and then once you've got all the lines on the diagram, to work out these different areas, you know the formula for the area of the triangle, right? The area of the triangle is half base times height. Okay, so that's all you have to do. Think in terms of the diagram and it'll make your life a lot easier. Okay, so that's for linear demand. Then asks you to do the same thing under isoelastic demand. Okay, don't do this bit under isoelastic demand, that's a bit tricky. Okay, but the nice thing about isoelastic demand, what you're going to see if you have a go at this evening, hopefully, we've got isoelastic demand, linear cost. Under monopoly, what you get is the price is a constant times marginal cost. C dash Q is marginal cost. This is just a constant depending on the elasticity. So with isoelastic demand, you get markup pricing. Okay, this is what a lot of firms do in reality. They say, well, my marginal cost to produce a mobile phone is 80 quid. I want to make 20% profits, 20% markups. Therefore, I'm going to set the price at 1.2 times 80 quid. Okay. So this is one nice way of getting markup pricing. With a monopolist facing isoelastic demand, we're going to endogenously get this markup pricing where the firm's going to set price as a constant multiple over their marginal cost. Okay, and we'll go through the maths of this tomorrow in the class. But if you have a go tonight, you'll see where you struggle, and that'll be helpful for tomorrow. Oh, actually, I've got fewer slides than I thought I did, so maybe we can do one of these now. Okay, you're being very quiet. Why don't you have a go at the linear problem? Just have a quick go yourself. See how far you can get. Just try and see if you can derive these two formulas. Okay, you know the answer, you know where you're trying to get to, so that should help. P0 and P1 are just constants. Hopefully the notation isn't confusing. So a few of you have got the answer now. Maybe I'll give you another minute or two. I could put this. Putting that up so I can write in the middle. Okay, so let's start with the easy one. How do you get the price under perfect competition? So what are you doing to get the price under perfect competition? Okay, so under perfect competition, we want to find the point at which price is equal to marginal cost, right? So P of Q is equal to C dash of Q. Here's our function C. So C dashed is just C1, and P of Q is what we had, P0 minus P1Q. So we want to find P0 minus P1Q is equal to C1. Add P1Q to both sides, subtract C1. Okay, so P0 minus C1 is equal to P1Q. So divide by P1, it must be that Q is P0 minus C1 divided by P1. So that's very easy, price under perfect competition. Does this make some economic sense? So you can think of P0 as being kind of their valuation, if you like, or the most they'd ever be prepared to pay for the good. So when P0 is big, they're prepared to pay more for the good, so the monopolist wants to sell more. Okay, if people are prepared to pay more, then it's in your best interest to sell more. If C1 is this marginal cost, okay, if marginal costs are very high, then you don't want to sell too many, because as you sell more and more, your costs are increasing, right? So higher the marginal cost, the fewer you want to sell. That makes sense. And then we're dividing by P1. So P1 is giving you the slope of the demand curve. So if P1 is very big, that means demand, it means people never want to demand very much, right? If P1 is big, we've got a demand curve that looks like this. Okay, so people just don't want that many units of the good, full stop. Okay, so if P1 is big, people don't want too many units, so you better not sell too many units. Okay, so quantity is going to be small. Whereas if P1 is low, then it's flat, quantities should be higher. Okay, you know, we're looking at the point where price is marginal cost, clearly it's going to move up. Okay, so that all makes sense. Let's look at the monopoly case. Okay. Okay, so what are profits? Okay, so monopolist profits are price times quantity minus total cost. Okay, always the same. So here we're working with the inverse demand curve. Okay, we're working with this expression for price. So price is P0 minus P1Q, all times Q, minus C of Q, which is C0 plus C1Q. Okay, so the monopolist is going to choose how much to produce in order to maximize profits. So we want to take that first order condition, which is d pi dq. Okay, and what is this thing? Well, let's use the product rule on this bit. Okay, so derivative of this bit, which is minus P1, times this bit, Q, plus this bit times the derivative of that bit. Well, the derivative of this bit is just 1. Okay, so this is going to give us plus P0 minus P1Q. Alternatively, you could have multiplied out the brackets. Okay, so then you would have had P0Q minus P1Q squared. How do you differentiate Q squared? Well, you get 2 P1Q. Here we've got 2 P1Q. Okay, so it would have given you the same thing. And then Q doesn't appear here. Remember, we're differentiating with respect to Q. It does appear here. So we're going to get a minus C1. So that's not too hard. All we have to do now is take all the Q's over to the other side. So we have 2 P1Q is equal to P0 minus C1. So Q is equal to P0 minus C1 over 2P1. So that's very easy. Everyone did that? So let's have a go at the isoelastic case now. So this is the important bit. Okay, so just write down what our price function is. So cost function is the same as before, but now our price function is k q to the minus beta. Okay, and we want to show that the monopolist is going to choose price equal to 1 over 1 minus beta c dashed of q. So profit's always the same, it's always price times quantity minus total cost. Okay, so P, Q minus C, Q. C as a function of Q. People get confused with brackets sometimes being functions, sometimes being something else. Okay, so let's plug in. So price is KQ to the minus beta. So we've got KQ to the minus beta all times Q minus C0 minus C1Q. Okay, so what's this thing? How do we simplify that? We're very shy. So we've got 1 q here, we've got minus beta q here. So in total we've got 1 minus beta q. Okay, minus. Makes our life a bit easier of differentiating. Okay, so the firm is going to choose quantity in order to maximize profits. If you're doing an exercise, ideally you would write that down, and then you'd say at a maximum, it must be the case that naught is d pi dq. Okay, so we just have to do the differentiation. What do we get when we differentiate this term? Someone said 1 minus beta. Okay, yeah, I think you know. Okay, so this, remember the rule is x to the n goes to nx to the n minus 1. Okay, so here this is our n, so we get k times 1 minus beta q to the 1 minus beta minus 1, which is just minus beta. Does that make sense for everyone? And then derivative of this bit is naught, doesn't have a q in, so then we just have the derivative of this bit, which is minus c1. So this isn't too funny. What do we have here? We've got k times q to the minus beta. What's that? Do you recognize k times q to the minus beta? Yeah, it's the price. So all we have here is k times the price minus c1. Oh, I missed it. No, not you. K times q to the minus beta is the price. So but we have a 1 minus beta bit left. So this is 1 minus beta times the price minus c1. Okay, we're just substituting from this relationship the price as k q to the minus beta. Okay, so take c1 over to the other side, divide by 1 minus beta, and we get price is c1 divided by 1 minus beta. Okay, price is marginal cost divided by 1 minus beta. So this monopolist will always like to set price as a constant markup over marginal cost. So for example, suppose beta was a half. Okay, if beta is a half, 1 minus beta is equal to a half. Dividing by a half is the same as multiplying by 2. Okay, so when beta is a half, the firm's always going to set price at twice its marginal cost. As beta gets closer and closer to 1, what's going to happen to prices? Someone said smaller. Smaller to 0. Who thinks prices are going to get smaller? Who thinks prices are going to get larger? The smile maybe gave it away. Yeah, prices. So as beta goes towards 1, this thing is going to go towards 0. When you divide by something very small, you get something very big. Okay, so prices are going to go towards infinity. And with beta equal to 1, the monopolist would like to set an infinite price. So beta equal to 1, that's the case when price is k divided by q, which is what I actually started with. So if you have a demand curve like that, the monopolist actually maximizes profits by setting an infinite price. What about if beta is bigger than 1? What goes wrong when beta is bigger than 1?
Shouldn't sell anything.
So yeah, okay. So with beta bigger than 1, this thing's going to be negative. So if you believe that the first order condition was telling you the right thing, the price would be negative, which clearly doesn't make any sense. There's something funny is going on in there. Well, what happens when beta's bigger than 1. Okay, suppose that P is equal to, I don't know, K over Q squared. Okay. So what does it look like? What do profits look like in that case? Well then, profits are PQ minus CQ. Okay, so price times quantity, K divided by Q, minus whatever costs are. So normally, you know, for a normal firm, revenue is going to be increasing as you sell more units, at least initially, right? Here, as Q increases, revenue falls. If you sell 0 units, it's like you get infinite revenue. Okay, so in this case, there's not an internal solution. The solution is, like you said, set Q equals 0, or approximately 0, then you get infinite profits. Okay, so this goes back to what I said at the start, but you have to be a bit careful about just setting marginal revenue equal to marginal cost. Okay, because marginal revenue equals marginal cost, that comes from the first order conditions, and the first order conditions are only going to be valid when there's an internal solution. Okay, so if you've got some maximization problem, you know, this is where the first order conditions are coming from, right? We want to maximize the function, it's flat at the maximum. Okay, but suppose it has to be positive, and rather than looking like that, it instead looks like this. Okay? Then maybe if you carried it on, there would be a maximum for some negative value, but that clearly doesn't make any sense at all. So what should you do in this world? Well, you should choose at the boundary. Okay, you should set quantity 0 here. Okay, so when you maximize, you have to think: have I really found a maximum? Okay, if you get an internal maximum which is negative for something that has to be positive, then something funny is going on, and you need to have a think about it. You know, so these. So this might seem like a kind of funny mathematical oddity that firms would like to set infinite prices or 0 quantities. But if you actually estimate demand curves, you know, would be plausible markets where you might get a demand curve that looks a bit like this. And we'll see that things are a bit different when you have multiple firms. Okay, so when you have multiple firms maybe competing in quantities, like under corner competition, things are going to be well behaved even when you have one of these funny, very steep demand curves. What do these demand curves look like? They're really... So when Q is small, Q squared is really very small. Okay, so this thing is really very big. So these demand curves look something like that. They're incredibly steep, close to the origin. So, you know, people are prepared to pay almost an infinite price to at least have some of the good. And if you think about, I don't know, demand for water, say, it might look a bit like this. You know, if you hadn't drunk for 4 days, you're walking in the desert, okay, you're going to be prepared to pay almost everything you have in order to have a sip of water. So these demand curves, incredibly steep around 0, might not be so impossible. So maybe a monopolist would like to set an infinite price for water. Or just a few other exercises. What are we doing for time? Let's just turn the off. So on the next slide, I gave some other. Let me just borrow. Turned up. Fine. The last. Thank you. Yeah, so on the last slide I gave some exercises for Mod Shy. We'll go through as many of them as we have time for in class tomorrow. I also asked you to redo those exercises with a monopolist choosing prices instead of quantities. Okay, so rather than having linear in quantities, have linear in prices. Things are going to be pretty similar, but it's a useful exercise. You know, you want to do these things lots of times so you can do them in your sleep without even thinking about it. And then we're some exercises for my shop. Sorry about that. Have a good evening.